The National Electrical Code, or NEC, sets specific requirements for electrical installations, especially in hazardous locations like gas stations. Section 501.5 A2 addresses conduits emerging from the ground, stating that conduits must be threaded into a fitting within 18 inches of the point of emergence. Section 501.5 B covers the protection of conduit from physical damage, requiring either burial or protection by rigid metal conduit, intermediate metal conduit, rigid non-metallic conduit, or Schedule 80 PVC conduit at a depth of not less than 6 inches. Now consider a gas station installation where the electrical contractor ran conduit from the side of the building using LB, then transitioned to PVC underground to a 5-foot gutter, all in PVC. From the gutter, 3/4-inch conduit runs to the pumps using a 6-inch nipple in EMT to a 3/4-inch galvanized seal-off, then galvanized pipe to the bottom of a trench, followed by PVC. Let's analyze these elements against the NEC. Firstly, the use of LB to transition from EMT to PVC underground without additional protection is not permitted. The conduit should be threaded into a fitting within 18 inches of the point of emergence from the LB. Secondly, running EMT to the galvanized seal-off and then using galvanized pipe is not compliant with the NEC. EMT is not approved for burial unless it is encased in rigid conduit. Thirdly, running PVC directly under the trench without any protection is also not compliant. The PVC conduit should be buried at a depth of not less than 6 inches or protected by a rigid conduit. To correct these deficiencies and bring the installation into compliance with the NEC, specific actions are required. 1. Install a threaded fitting within 18 inches of the point of emergence from the LB and thread the PVC conduit into the fitting. 2. Replace the EMT with rigid conduit or intermediate metal conduit and protect it from physical damage by burial or running it through a larger rigid conduit. 3. Bury the PVC conduit under the trench at a depth of not less than 6 inches. In summary, the initial electrical installation at the gas station did not comply with the NEC requirements for conduits emerging from the ground and for protection from physical damage. Corrective actions are essential to ensure the safety, proper functionality, and code compliance of the installation. It's crucial to understand that electrical installations in hazardous locations must adhere strictly to the NEC to prevent potential hazards. Always consult the latest edition of the NEC and seek guidance from qualified electrical professionals when designing and installing electrical systems in gas stations and other hazardous areas. Let's delve deeper into the specific code requirements and the reasoning behind them. Section 501.5, which governs wiring methods in Class 1, Division 1 and 2 locations, addresses the proper installation of conduit to ensure safety and prevent explosions. The requirement that conduits emerging from the ground be threaded into a fitting within 18 inches of the point of emergence is intended to minimize the risk of damage and potential entry of flammable vapors or gases into the conduit system. The 18-inch limit is a practical measure to ensure that any necessary sealing fittings are located close enough to the potential source of hazard to be effective. When using LB or conduit bodies to transition from one type of conduit to another, it is critical to maintain the integrity of the conduit system. Without a threaded connection into a fitting within 18 inches, there is a risk that the connection could loosen over time, allowing moisture or hazardous substances to enter the conduit. The NEC also mandates the protection of conduit from physical damage, as detailed in Section 501.5. This section recognizes that underground conduit is susceptible to damage from various sources, including digging, ground movement, and corrosion. To mitigate these risks, the code requires that conduit be either buried at a sufficient depth to prevent damage, or protected by a more robust type of conduit. The acceptable methods of protection include rigid metal conduit, intermediate metal conduit, rigid non-metallic conduit, or Schedule 80 PVC conduit, installed at a minimum depth of 6 inches. EMT, or electrical metallic tubing, is generally not approved for direct burial because it is relatively thin-walled and susceptible to corrosion. Although it can be used in some underground applications if encased in concrete, it is not suitable for direct burial in areas where it may be exposed to moisture or corrosive substances. In the gas station scenario, running EMT to the galvanized seal-off and then using galvanized pipe is a violation of the NEC because EMT is not approved for burial unless encased in rigid conduit. Seal-offs are used in hazardous locations to prevent the passage of gases, vapors, or flames from one portion of the electrical system to another. They are typically installed in conduit runs that pass from a hazardous area to a non-hazardous area, or between different pieces of equipment within a hazardous area. Seal-offs must be installed correctly to be effective, and they must be accessible for inspection and maintenance. The NEC specifies the types of fittings and sealing compounds that are approved for use in seal-offs. Running PVC directly under a trench without any protection is another violation of the NEC. PVC conduit is a popular choice for underground applications because it is resistant to corrosion and relatively easy to install. However, it is also susceptible to physical damage if not properly protected. The NEC requires that PVC conduit be buried at a depth of not less than 6 inches to protect it from damage, or that it be protected by a rigid conduit. In the gas station scenario, the PVC conduit under the trench should be buried at least 6 inches deep, or it should be encased in a rigid conduit, such as rigid metal conduit or intermediate metal conduit. The required corrective actions for the gas station installation are intended to bring the installation into compliance with the NEC and to ensure the safety of the electrical system. Installing a threaded fitting within 18 inches of the point of emergence from the LB and threading the PVC conduit into the fitting will ensure that the connection is secure and that the conduit system is properly sealed. Replacing the EMT with rigid conduit or intermediate metal conduit and protecting it from physical damage will prevent corrosion and damage to the conduit. Burying the PVC conduit under the trench at a depth of not less than 6 inches will protect it from physical damage. These corrective actions are essential to ensure that the electrical system at the gas station is safe, reliable, and compliant with the NEC. The specific sections of the NEC that apply to this installation are found in Article 501, which covers Class 1 locations. Class 1 locations are those in which flammable gases, vapors, or liquids are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Gas stations are typically classified as Class 1, Division 1 or Division 2 locations, depending on the likelihood of flammable substances being present. Division 1 locations are those in which flammable substances are present continuously, intermittently, or periodically under normal operating conditions. Division 2 locations are those in which flammable substances are present only under abnormal conditions, such as a spill or a leak. The NEC provides detailed requirements for electrical installations in Class 1 locations, including requirements for wiring methods, equipment, and grounding. These requirements are intended to minimize the risk of ignition and explosion in these hazardous areas. In addition to Article 501, other articles of the NEC may also apply to the gas station installation, depending on the specific equipment and wiring methods used. For example, Article 300 covers general requirements for wiring methods and materials, and Article 310 covers conductors for general wiring. It is important to consult all applicable articles of the NEC when designing and installing electrical systems in gas stations and other hazardous locations. In conclusion, the electrical installation at the gas station did not comply with the NEC requirements for conduits emerging from the ground and protection from physical damage. Corrective actions are necessary to bring the installation into compliance and to ensure the safety and reliability of the electrical system. It is important to consult the latest edition of the NEC and to seek guidance from qualified electrical professionals when designing and installing electrical systems in gas stations and other hazardous areas. Let's consider a practical example to further illustrate these concepts. Imagine a scenario where the EMT conduit runs underground for a distance of 20 feet without any protection. Over time, the EMT is likely to corrode due to exposure to moisture and soil chemicals. This corrosion can weaken the conduit, making it susceptible to damage from digging or ground movement. If the conduit is damaged, it could create a path for flammable vapors or gases to enter the conduit system, potentially leading to an explosion. By contrast, If the EMT is replaced with rigid metal conduit and buried at a depth of not less than 6 inches, it will be much less likely to corrode or be damaged. The rigid metal conduit provides a robust barrier against physical damage, and the 6-inch burial depth protects it from most digging activities. In addition, the rigid metal conduit is less susceptible to corrosion than EMT, so it will last longer in the underground environment. Another important consideration is the proper selection of fittings and sealing compounds for use in hazardous locations. The NEC specifies the types of fittings and sealing compounds that are approved for use in Class 1 locations. These fittings and sealing compounds are designed to prevent the passage of flammable vapors or gases, and they must be installed correctly to be effective. For example, a seal-off fitting must be filled with an approved sealing compound to create a gas-tight seal. The sealing compound must be compatible with the type of flammable substance that is present, and it must be properly installed to ensure a reliable seal. In addition to the technical requirements of the NEC, it is also important to follow good workmanship practices when installing electrical systems in hazardous locations. This includes properly supporting and securing conduit, using the correct tools and equipment, and thoroughly inspecting the installation to ensure that it meets all applicable requirements. Good workmanship practices can help to prevent problems and ensure that the electrical system is safe and reliable. The NEC is a complex and comprehensive document, and it is important to have a thorough understanding of its requirements before designing or installing electrical systems in hazardous locations. It is also important to stay up to date on the latest changes to the NEC, as the code is revised every 3 years. Consulting with qualified electrical professionals and attending training courses can help to ensure that you have the knowledge and skills necessary to design and install safe and compliant electrical systems in gas stations and other hazardous areas. The consequences of not complying with the NEC can be severe, including fires, explosions, injuries, and even death. Therefore, it is essential to take the NEC seriously and to follow its requirements carefully. By doing so, you can help to protect people and property from the hazards of electricity in hazardous locations. The NEC also addresses grounding and bonding requirements for electrical systems in hazardous locations. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current to flow back to the source. Bonding is the process of connecting different metal parts of the electrical system together to create a low impedance path for fault current. Proper grounding and bonding are essential for preventing electric shock and minimizing the risk of fire in hazardous locations. The NEC specifies the types of grounding and bonding conductors that are approved for use in Class 1 locations, and it provides detailed requirements for installing these conductors. It is important to follow these requirements carefully to ensure that the electrical system is properly grounded and bonded. The NEC also addresses overcurrent protection requirements for electrical systems in hazardous locations. Overcurrent protection is the use of fuses and circuit breakers to protect electrical equipment from damage due to excessive current flow. Overcurrent protection devices must be properly sized and installed to protect the equipment they serve. The NEC specifies the types of overcurrent protection devices that are approved for use in Class 1 locations, and it provides detailed requirements for installing these devices. In addition to the requirements of the NEC, there may also be local codes and regulations that apply to electrical installations in gas stations and other hazardous areas. It is important to check with the local authorities to determine what codes and regulations are in effect. Complying with local codes and regulations is essential for obtaining permits and ensuring that the electrical installation is approved. The process of designing and installing electrical systems in gas stations and other hazardous areas can be challenging, but it is also rewarding. By following the requirements of the NEC, using good workmanship practices, and consulting with qualified electrical professionals, you can help to create safe and reliable electrical systems that protect people and property from the hazards of electricity. Remember that safety is always the top priority when working with electricity, especially in hazardous locations. Take the time to do the job right and never cut corners or take shortcuts. Your efforts will help to ensure that the electrical system is safe and reliable for years to come. The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with qualified electrical professionals before designing or installing electrical systems in gas stations or other hazardous areas.